Hello, welcome to the basics of macro programming. I have some very exciting syntax to show you, concepts, macro variables, and macro programs. So if you haven't seen them before, or if you have, there are definitely some things I'm looking forward to covering for you, to be introduced to you. So I want to go ahead and get started and just share my table of contents so you will see what we will cover in this session. There are two lessons. The first lesson is the macro basics. Just the first two topics will be the straightforward basics. And then secondly, the not so straightforward basics. So we'll start here, just the straightforward basics. First, start off with a poll question, multiple choice question. What is the overall purpose of the macro facility? And the answer is text substitution. Text substitution with macro variables. Text substitution with macro programs, which you can do it conditionally, you can do it repetitively. There are two components of the macro facility. There is the macro processor, which is part of base SAS that does the macro work. And then there's the macro language, which is a syntax for you to put together to either use a macro function, create macro variables, or define and execute macro programs. We will explore both concepts. Here's another multiple choice. Just to test, see where you are and with your experience, what are the two main tools of the macro language? Would it be data sets, macro procedures, macro programs, macro styles, or macro variables? The answer, macro programs and macro variables. Macro variables, as I mentioned, substitute text. It could be a person's name, it could be a table or a list of tables or a list of states, list of countries that we're doing some analysis on. Macro programs also tend to be text substitution at a much larger degree. So you might create a macro program that generates data steps and proc steps conditionally based on data, repetitively. There are two symbols that are recognized as macro triggers. The symbol with a word denotes a macro trigger. So what are those two symbols? Dollar sign, percent symbol, ampersand, asterisk. An ampersand typically precedes a macro variable to reference that macro variable to substitute information. The percent symbol is what you start off with to use a macro function, macro statement, define a macro program. Those are the two symbols that are regarded as macro triggers. They take some action by the macro processor. Let's look at some of these macro triggers. We have ampersand DSN, which is regarded as a macro variable reference, ampersand location, month. These are all macro variable references. So the macro processor would expect those, a macro facility would expect those to exist. A percent symbol is used typically to specify a macro statement like percent let, which you'll see. A macro, beginning of a macro definition with percent macro, you give it a name. Could be a macro function. Some of you have used scan and substring, where there are equivalent versions at the macro level, percent substring, percent scan, percent upcase. There's a percent do loop at the macro level. So there's some code you want to run repetitively. Let's say you have a certain path on your shared drive or your personal drive, and you want to repetitively convert Excel sheets to SAS data sets. That's one of the things you could do. You could process data sources in the same fashion. There are a number of things you can do with a macro do loop. Very powerful feature. Here's an example of the substring at the macro level. You proceeded with a percent symbol, substring, and then your argument would resolve to a string. Quotation marks are not necessary. You indicate the starting position and optionally the end position, how many characters you want. If you reference a macro variable within quotation marks, you have to use double quotation marks. Macro variables do not resolve in single quotation marks. If you wanted to resolve not as a literal, then you do not put quotation marks around. For example, we want 20 to resolve just as a number, even though it's stored as text to resolve as a number. And here, within quotes, I want it to resolve to MAR. Within these quotation marks, you have a macro trigger that's a percent symbol. So it might be that you're using a macro program to return some result, which could be a data set name. In fact, we will see an example of that. More questions for you. Multiple choice once again. What are the 3 methods of creating a macro variable? We have a list of 6 items. %let can be used to assign a value to a macro variable, especially if you know exactly what you want it to be. Call SYMPUTX is used in the data set. You can use that technique to create a macro variable when you really don't necessarily know what the value looks like if it needs to be computed. So maybe you're generating a statistic or doing some kind of data manipulation, and you don't necessarily know what that value looks like, but you can still have it dynamically generated for you. The other technique is procSQL into, one of my favorite options for creating macro variables and creating a series of macro variables. There's this into clause that you use with a colon to indicate what macro variable you're creating, and prior to that, you have some value that you're assigning to it. It could be a statistic, it can be a computed value. So those are your 3 answers: %let, call SYMPUTX, and procSQL into. Let's start with %let. %let creates a macro variable as follows. %let, you give it a name, and you assign it a value. That value will be stored as text. If you bound it within quotation marks, quotes are stored as part of the value. The next approach we will look at is called SYMPUTX, where you can create a macro variable at execution time. The reason I mention execution, because you might have some data coming in that's being executed and do some kind of calculation that you are not aware of as far as what value you get. And the second argument is the actual value. So there's at least 3 ways. There's 3 ways you can indicate the macro variable name and the value. The third technique is the into clause with SQL. And once again, you could do a calculation for procSQL. You might be doing some mean statistic or min max, or perhaps you are changing the case of some text. Perhaps you're concatenating some values and you want to put it into a macro variable. Notice there's a colon before the name. You have to put the colon. Here's an example of %let. When I know exactly what the value should be, I can do %let year current equals 2020. %let year previous equals 2019. I could hard code the values or have it calculated as down below. The advantage of this technique is next year when I run it, it will take care of itself. I don't have to hard code 2021, previous year 2020. Let's take a close look at what's to the right of the equal sign. By the way, when you create a macro variable with %let, you don't put an ampersand in front of the name. If you do, it could be that it's a macro variable reference that resolves to a legitimate new macro variable name. So that would be acceptable. In this example, we're using a function called %sysfunc. %sysfunc can invoke a number of functions in SAS. Not all of them, but probably the majority of them. In fact, what I'm using, for those of you who are familiar with the today function, the today function returns a SAS day for whatever today is. And I'm using sysfunc to invoke that function to return that integer. Once that integer is returned, I'm using a second version of sysfunc to invoke the year function to return a 4-digit year. So that should return a 4-digit year for whatever today is. And the second one is doing math. It's using a %eval, like evaluation, but %eval only does integer arithmetic and does not do non-integer arithmetic. If you want to do non-integer arithmetic in integer, then there's %sysevalf you can use. In this case, we're just subtracting 1 from ampersand year. well, ampersand year current. So this would end up being 2020 minus 1, which is 2019. We assign that to previous year. Here's the new example. And what I'll do at the end of this lesson is to bring the programs in and show you the result through one of our interfaces. Remember I mentioned %let, called SYMPUTX, and SQL into. This is called SYMPUTX. This data step runs only one time. It's really for test purposes, just to really show you something. It could be that you're doing a calculation and you have no interest in a data set being created. So this is how you would do it. You would put data underscore null underscore, and it would not create a data set. It would still allow you to use the data set. As in this case, we're creating a variable called YC. So we make it equal to the year of today. Remember, you will get the, well, we're not using sys function because this is a data step assignment state. We will get the SAS date from the day and the 4-digit year from year function, whatever today the year is, current year is, and assign it to YC. Then YC minus 1 is assigned to YP. So we're trying to imply year current, year previous. So this is a new example in creating the same macro variables I created here. But I'm using call SYMPUTX to have it generated for me. Call SYMPUTX. The name is first and the value second. Remember the syntax. The name is first, the value second. So I'm assigning YC to the macro variable called year, and the value of YP to the macro variable called year previous. Notice the name goes in quotation marks. The value in this instance will be a data set variable whose value is assigned to these macro variables respectively. Now, it could be that you're assigning a value in quotation marks or assigning a value from an expression. Let's say you're concatenating first name, last name, and when that expression finishes, that value will be passed to the macro variable name. So actually, the name or the value could be indicated 3 different ways: as a hard-coded value in quotation marks, as a value of a variable, or the value built from an expression. In this example, we're creating a series of macro variables. If you have not seen underscore and underscore before, that indicates the number of iterations of the data set. This is a variable that's created automatically in what we call the program data vector, or just know that it is available. And what I'm trying to construct, if remember we're using call SYMPUTX. So the first argument generates the name, the second argument assigns the value, gives us the value. So if you take a close look at this first argument, it is actually an expression. We're doing some manipulation that yields a value. That value, the current value, will be the name of my macro variable. So basically, bottom line is, I'm concatenating the word student with the value of underscore and underscore, which starts at 1, and then increments by 1 and continues to go up. So the first time, the name we will generate will be student 1, and whatever the value is from SAS help class will be assigned to student 1. SAS help class, we all have. Each of you have access to this data set. There are several data sets in the SAS help library that you can use. And this is just one that we're putting in this example. All right, if last. So n equals last is creating a variable called last that will indicate if we are at the end of the data set, if we have read the last observation, last record. The reason I'm doing that is because I want to create an additional macro variable called count, and I'm assigning it whatever the current value of underscore n underscore, so I'll know which iteration I was on, which basically will tell me how many of the student names I have. And it will put that value in that macro variable called count. So I will end up with several macro variables, student 1, student 2, student 3, and whatever the count is indicating how many how many iterations I went through the data set. The SQL into is another option to assign a macro variable value dynamically where you don't necessarily know what it looks like. In this particular case, I'm putting the maximum year from a data set called PRD cells. Let's say I have several records in here. Whichever year has the highest value among the records, I want to put it out as a 4-byte character string. The put function writes the numeric out as a string. I'm putting it out as a string and then put it into a macro variable called year max, colon precedes it. The data is coming from work.prd set. So if I have 10 records, whichever value is the highest of year among those 10 records, it will retrieve that value as the max and put it out as a 4-byte string into that macro variable called year max. For each macro variable I create, notice I'm preceding it with a colon. So I have 2 values I'm assigning, separated with a comma. I want to put the max out as a 4-byte string into year max and put the min value out as a 4-byte string to year min. So I'm creating 2 macro variables from PRD cell. And I can use those further down in my code somewhere, maybe in a title, maybe in a footnote, or maybe in some conditional logic. Distinct or unique, either word would work. So I want to take distinct makes of a car like Chevrolet, BMW, Acura. In SAS help cars, I might have multiple records for a particular make, like Chevrolet, but I only want the distinct values. So select distinct make into colon a macro variable called car makes, separated with quote by quote. So what is going on? What it will do is make a distinct list of the makes and assign that list of values of the make of the cars into this one macro variable called car makes, separated with a space. So you might have Chevrolet, space, Porsche, space, Mercedes-Benz. They will be separated with a list in the list by blank. So you could use that perhaps for validation. You can use it for filtering. There are a number of places you can use that. Here's an additional example. What if you want to assign a series of macro variables, make 1 through make 38? Let's say you know your data and there's only 38 different makes of cars. So you do a select distinct make into colon, you start at make 1. So the first make from the SAS help cars will go to make 1. The second make of the automobiles from SAS help.cars will go to make 2, make 3, make 4, and so on. All the way through make 38. So whichever one is last, that 38 record, whatever it contains, that value will be assigned to make. Let's say you don't know how many you have. You can just put a hyphen. Very nice feature. It will count them for you. If you have 38, the last macro variable would be make 38. If you have 50, the last one would be make 50. Down at the bottom, there's a reference to an automatic macro variable. Not the ones you're creating, but an automatic one that you get whenever you use ProcSQL. And you can put that to use. It's called SQL OBS. It will tell you how many records you have in the result set, the result of that ProcSQL set. So if I'm trying to do something iteratively with a macro do loop, I want to know how many I have because I can use SQL OBS. In this case, since I have 38 makes, SQL OBS will also be 38. It tracks the number of rows that were produced. Here's another poll question for you. Where are macro variables stored? Where are macro variables stored? 2 places you can store a macro variable. In a local table or a global symbol table. Local symbol table or global symbol table. So it depends on where you define your macro variable or variables. Local or global symbol table. When a macro variable is created, the macro processor adds the macro variable to the symbol table. So there's two types. There's global and there's local. sysdate9 is an automatic macro variable that's put in the symbol table automatically for you, along with a host of other automatic macro variables. Now, these last four were created, perhaps by you or whoever the programmer is or analyst is who's writing the percent less, so using call SYMPUTX or SYMPUTX. User defined are the last four. The first one is an automatic one that you get from SAS. SAS creates for you, and you can use it if you like or not use it. Global symbol tables. Whenever you start your SAS session, this table is created automatically for you. And it's global. It stays around your entire session. So whatever macro variables you put in there, you're good for the entire session. You get the automatic ones that SAS creates for you, automatic. And if you define macro variables outside of a macro program, they're also placed in the global symbol table with %let, call SYMPUTX, ProcSQL into. So what about the rule for the local symbol table? The local symbol table is only created when you have a macro program that starts executing. And that local symbol table is only good while that macro program is executing. After it's finished executing, gone. That table is gone. So what can you put in there? It can store macro variables defined as local inside of the macro program. So there's a statement called %local. And whenever you have macro parameters, if there are macro variables, they are automatically placed in the local table. Which statement displays the value of a macro variable in the log? %put, not put. Now there's a put statement in the data set. There's also a put function, but we're referring to the %put macro statement. If you would like to see all of your macro variables, you can type %put, put a space, underscore all underscore semicolon. That will show you all of the global macro variables plus automatic. The globals are the ones that you created. The automatic ones are the ones SAS set up for you when you started the session. You will see both. But what if you don't want to see both? What if you only want to see the automatic ones? Then you would do a %put underscore automatic underscore. And what if you only want to see the ones that you create? Then you could do %put underscore user underscore. So you can see them all. You can see the automatic ones. You can see the ones that you create, underscore user underscore. Or you can be explicit and display specific macro variables, like ampersand month and ampersand year with a %put statement separated with a space, and that's exactly what you see here. They're separated with a space. Here's the next example. If you like to view it like an assignment in the log, and by the way, this is in your SAS log, the %put writes to your SAS log on. %put ampersand equal, you see the ampersand, that's a macro trigger. Instead of being in front of this L, we put an equal sign here. So we'll write it in the log like an assignment. Location equals District of Columbia. Notice when you do a %put, you put the ampersands, but in the log, you don't see them because they resolve. Here's an additional one. %put today is ampersand sysdate. This is an automatic macro variable for when you started your SAS session last. %put. Which statements start and end a macro program? Just a review. You've written macro programs before. It requires a %macro. You put the name of your macro program and a %min in the name of your macro program. You don't have to put the name of your macro program on the %min statement. You can just type %min semicolon. Here's an example. %macro myd t time. That's the name of the macro program. %min concludes that macro definition, calling it the same name. So what's embedded within this macro program is these 4 statements. It doesn't execute it at this point, it's just defining it. If you had macro level statements, it would check those like a %if, %then, %do. We don't have any of those in there. Remember the name, NYDT time. When you call it, it will create these 2 macro variables. Remember sysfunc, we're writing out the date. The date and the today function give you the same exact thing. They give you the SAS date for the day, and we're displaying it with a format. When you use sysfunc, you don't have to put a format. For example, if I put a parentheses where the comma is and then the semicolon, it will just display it as the number of days between Jan 1st, 1960 and today. You can optionally put a second argument with sysfunc, which would be a format. So I'm using a format with a dot that writes it out like a word, and part of, is it explains the date. The second one, I'm writing out the time. So I'm using %sysfunc to invoke the time function, like I did the date function, and that returns an integer. For time, it's the number of seconds past midnight. And that's what you would see unless you do a format, assign a format with sysfunc to display it as time AM PM. So these 2 will create the macro variables within the macro program. Then the %puts will write out the values of date and time. Notice proceeded with ampersand to reference it. Not when you create them. When you create them, you don't have to put the ampersand. When you use them, you do. So when I call this macro program, it will take these actions, do all 4 of these things. You don't need a semicolon. In fact, depending on where you call it, a semicolon might cause you issues. So if you just do something like this, typically you will not have an issue. But a semicolon is not necessary. It is still used to denote the end of a SAS statement, and not here. And as you can see, we get the notes in the log because %puts right to the SAS log. Which 2 methods are valid for specifying parameters in a macro program? In other words, what are the 2 kinds of parameters that you can have? One is positional, one is keyword. We will see both. Positional, keyword. So here's the story with positional map parameters. And I would say 90-something% of the time, the parameters will end up being macro variables anyway. So when you define them, they're based on position, whichever one you put first and second, because when you assign values to them, if you call the macro %cars, open parentheses, the first thing you type must be the make, comma. The next thing you type must be the cylinder value. So when you do a macro definition like this, when you eventually call it, you have to be cognizant of the fact of the position. So whichever value you put first goes here, second value goes here. If you put them in reverse order, you will get the incorrect value going to these respects. Now, an alternative to positional is keyword, where you actually assign default values. Like I'm indicating the make be Audi, like Audis, and then cylinder equals 6. If I was to call the macro program cars, %cars, and just put parentheses, these will be the default values. So typically in a macro program, you're going to substitute these values somewhere in the code that's embedded within macro program that you're going to have submitted to be processed. Remember we talked about, I explained the global symbol table and the local symbol tables. Parameters always go to the local symbol table for that macro program. And they will be created when cars start to execute, and they will be removed when cars is finished. This is just defining cars. You have to do a %cars as we do here to have it execute. So from here to here is the definition. This is a call to have it execute. We have two positional parameters. And if you look where we're calling it, these values have to be aligned respectively in those positions. Make, forward, cylinder, 8. If you reverse these two, 8 will go to forward, 8 will go to make, and forward will go to cylinder. Get some errors. You will get some errors because it will be treating the cylinders as if it's letters F-O-R-D, and it will think it's a variable. So in this prompt print, I'm going against sashelp.cars, where there's a column in SAS help called make equals in quotation marks because I want it to be part of a literal, and that will resolve the forward, and cylinders equals 8. Run statement. It will send that proc print, process that proc print, and give you a listing based on your request. Positional parameters. When you define them, when you call them, they have to be in the same order, respectively. What about keyword? Keyword, you set defaults. I probably would have made by default Mercedes-Benz or Porsche. We'll go with the Audi. Cylinder 6. When I call this macro program cars, I'm overriding the default value of cylinder. I decided, let's go with a 4-cylinder. Give me the makes of Audi with 4 cylinders. So in the where, make will be equal to Audi, and cylinders will be equal to 8. So when you have keyword parameters, you don't have to specify any value. Just put the parentheses and use the defaults. And if you want to override either or both, you certainly can. And they don't necessarily have to be in any order. You can do cylinder equals 4, comma, make equals Chevrolet or Audi or whatever. Which two statements are valid in a macro program? All right, so percent do and percent in, they're valid. Percent if, percent then, and percent else. Those are the two sets of statements. You can only use these inside of a macro program, not outside. They're only relevant within a macro program. You're doing something repetitively, or maybe you're submitting some code conditionally. Here's a do loop. One of my favorite features of the macro facility. If I want to do something repetitively, I can use a macro do loop. There are some I/O functions I can use to open up a directory, and I can have it search the directory looking for certain file types. So I can have it do a percent do from the beginning of that path all the way through the end of that path and just check files and do something repetitively. Or maybe do a proc print against a list of tables in the library, do proc univariate against a list of tables in the library. Doing something repetitively. Check out the syntax. Percent do, checking a macro variable equals some start value. You have to type %2, some stop value. So start and stop should be integers or macro variable references that resolve to integers. And you can do things conditionally too. Another favorite component of the macro facility of mine. Percent if some expression, percent then take some action. That could be use a macro function, assign a value to a macro variable, resolve a macro variable, or call a macro program. Percent else, percent if, and continue. Now, I don't have a do block here, but I can actually percent if some condition, percent then, percent do. Do a set of statements as a unit based on the true or false. So here's the example of a macro do loop. Now, I happen to know there are at least 38 makes in that SAS help cars. So I'm having this proc print work 38 times, and I'm filtering one of the makes at a time. I'm using the percent scan to go against the value of the macro variable makes and grab each one position at a time. If you recall, percent scan is very similar, and that amper I is automatically that variable. That whenever you do a percent do some variable equals something, that variable will automatically be a macro variable. I like that. That works really great for me. So I will automatically be a macro variable, and this value would change for each iteration. Initially it's 1, so this will be a 1, and I'll scan makes for the car to grab the first one using a tilde as the delimiter. So you might have Chevrolet, tilde, Dodge, tilde, Porsche, tilde, the next one. And I'm putting that same value in my title, so I'll know exactly what I'm getting. And all I have to do next is call percent all cars, and it will use the percent do loop to process and generate 38 proc prints for me. And I may be putting them in a PDF or some other file structure. If I know what they look like, I can go ahead and hard code the values or check those values. Percent if amper make equals Chevrolet, or you don't need a percent symbol here, by the way. Ampersand make equals Toyota, percent then percent do a proc print. Filtering for that make. Putting a title in for that make. And it's not a proc print, it's a proc freak actually. And I'm using a table statement to do a frequency on the cylinders. And then percent n for the do block. And then further down you have a percent net. So the point is you can submit code conditionally through a macro program. Here's the then for proc freak, the percent else do is a proc print. So notice percent if, percent else, percent then, percent do have percent symbols, but not or. So the first call would be for Chevrolet, and it would check ding 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 Chevrolet, and it would do a proc print, proc freak for the Chevrolet. The next call will be Toyota, and it will check once again, do a proc freak on the cylinders, and then lastly Acura. It's not in that list, so we'll go to the else do block and process for Acura. Excellent. You don't need a semicolon. Unnecessary. It'd be as if you put 2 semicolons here. It would be harmless in this case, but unnecessary. Here's another multiple choice question. Which SAS system options are useful for debugging in your macro facility, just in case you make some mistakes? Syntax-wise or logic-wise? There's actually 3. mLogic, mprint, and SymbolGen. SymbolGen is for resolving macro variables. Mprint is for showing you the code from a macro program. mLogic is really good because you can see the evaluation result of a percent if type inquiry at the macro program level. It will let you know if it was true or false. It also tracks the beginning and end of your macro execution. Those 3. All right. As I stated, mLogic specifies whether the macro processor trace your execution for debugging. All right. It will also give you the result of percent if then else. Mprint will show you the code is generated by the macro program and submitted to be compiled and executed. SymbolGen will show you the resolution of macro variables. All very handy. Here's an example. Return on all 3 options, mLogic, mprint, and SymbolGen. I'm calling this macro program for Chevrolet. Watch what mLogic does. It shows you the beginning of execution. And if that macro program was calling another macro, it will show you that beginning as well. Here's mLogic again. What parameter MK has been assigned, in this case Chevrolet. Here's SymbolGen, macro variable MK resolved to Chevrolet. Every time it's used, it will have a SymbolGen. So if you use make twice, you'll get 2 SymbolGens. 3 times, you get 3 SymbolGens. And here's mLogic once again. As I stated, I like it because it will indicate if that percent if, percent else resulted to true or false. Check it out, true. Right, we call for Chevrolet, it is Chevrolet. That's a true. Mprint will show you the code is generated. Here's a proc freak. Here's SymbolGen again. is the other part of imprint, the where in the table, is showing you the code that's being submitted by the macro program. Then, as I stated, SYMPUTX will show you the resolution of the macro variables wherever they are used. And then here's imprint continue is the title, and then the last part, which is a run statement. Now, to be honest, I probably wouldn't turn all of these on at the same time. I'll oftentimes put mlogic with imprint if I want to see what's happening with my macro program. And then if I want to see the macro variables resolve, I'd probably use SYMPUTX by itself. That's just me. That's how I do it. All right, so that concludes the first part, the straightforward approach, the straightforward basics. And what I'm going to do now is just walk you through some sample code of some of the things we just talked about. So I'm going to pause here for a moment and switch to my session, my interactive session, my virtual session, so we can look at some examples. So I have an enterprise guide session going here. And I have some programs you can see to the left, broken down by chapter. I'm just going to go and select my chapter 1 section, that's SAS programs, that go through a number of things we just talked about. Remember, we started off talking about macro variables, right? And here's a %let that I'm using to create 3 macro variables. By the way, if either the value, which is on the left of the equal sign, or if the name, which is on the left side of the equal sign, or the value, which is on the right, if either has macro triggers, they would have to resolve first before the assignment is made. Then notice I'm writing out each of these macro variables with a %put. So let me just highlight this, run these statements. I'm going to do a submit and show you in the log. Here are the values. DSN is the data set, SAS help. And then location is District of Columbia. Remember, we assigned that here. And then MAR has MAR, that text. And here I put DSN equals SAS help.class. And then I can use %put to write out the values of these macro variables. Let's move further down. I'm going to create a data set called work.class. The reason is I have an automatic macro variable called syslast that tracks the name of the most recently created data set. So since I'm creating work.class from SAS help.class or some other table, whatever the name of this recently created data set is, it will be assigned to syslast. And I'm actually using a macro program called DSN, but not much going on other than resolving that macro variable. Right? Or having that macro variable reference, which would be resolved. So notice in %let, I have DSN equals a macro program. That macro program will return the resolved value of this and assign it to that macro variable called DSN. So I've got a macro program called DSN. I'm creating a macro variable called DSN. But here's the difference in terms of the triggers. The % symbol is used for this macro program. The ampersand is used for this macro variable reference. So let me run this, and it should come out as, let me run all of this. It should come out as work.class. Log. Here we go. Let's put out as work.class. We talked about a macro do loop. You can only use it within a macro program, %do loop appropriately. You don't have to call it that. %do year, and remember what I said earlier, whatever index you use, I, X, Y, whatever, this will automatically be a macro variable. That's a really nice feature. We're going to assign it 2010 %to 2020. And then percent put year value is ampersand year. When you have a macro do loop, you have a percent symbol in front of the word too. Percent in, and then the conclusion of it, and we'll call it. So let's see. 2010 to 2020. 2010 to 2020. And it writes out each statement repetitively. So generally, what I would do, I would have a block of code in here that I want to execute repetitively. It might be doing some analysis for groups of data in a file, or maybe creating a data set for each distinct value of a category in a file, like country or maybe region. Now I'm going to show you a feature. Normally the error, I'm going to put error colon. Errors come out in red. This is a way to use this keyword to write your message out in red. But the only catch is that it writes the word error. So see how it's written out repetitively? If you don't want the word error to be written out, and you notice it looks up here like it's an error, you can put a hyphen instead of a colon. And it will use the color associated with that keyword, which is red. See the difference? Why would I use this? Perhaps you're writing custom messages, so you want things to stand out in your log. You're writing a macro program, and you plan to have a group of people use it. I can use percent puts to write notes when maybe something happens that I don't expect, or maybe this will apply a value to a parameter I don't expect, and I can account for that. Another category that we discussed is the macro function. Now there are functions in the data set. The macro says, hold on, I got functions too. Percent let is creating a macro variable called date. I'm making it the 29th of March, 2020. Percent let year equals the substring, percent substring of ampersand date. Now ampersand date will resolve to exactly what we're assigned at the top. And we're going to extract from the 6th position for 4 characters. So let's count 1, 2, 3, 4, 5. The 2 in 2020 is the 6th position. So we start here for 4. And that's what we would get assigned to the macro variable year. If I remove the comma 4, I would get the same thing because there's nothing after this. But if you don't put an ending point for how many characters you want, and it's really how many characters you want after the 6, it will continue until it grabs everything following. So it might be longer. If I want to be more explicit, I will tell it exactly how many characters. And once again, I just want this to stand out in red. So I'm going to type error hyphen and run this, and you can see the use of this macro function. Here we go. This is date, and this is the year that was retrieved with percent substring. It resolved this to text, and it started at position 6 for 4 characters, and that's what we know. You do not need to put quotations around this value, because if you do, quotes would be part of the value. Let's focus on the next example. You've actually seen this one where we just have a macro variable reference within a macro program. So when I call this macro program, it will resolve to ampersys last, which will resolve to the most recently created data set. So since I ran this earlier, it is still the most recently created data set. It should be, unless I miss something. So let's run this. In addition, in the title, it will show me my recently created data set as well. Here we go. Work.class. That's the data set name that we created from SAS help class. We'll continue down to this section. using %let and some functions like sysfunc to invoke other functions. I'm making year current 2020, previous 2019, and I'm putting them out next to each other. You've seen this in the slides. You get the same result, 2020, 2019. I'm just going through the programs now. And here's sysfunc. I have two occurrences of it because this one will return the SAS date for today, whatever today is. And then this sysfunc will invoke the year function, return a 4-digit year. %eval and %sysevalf can do math, and this is just a simple subtraction. And then when I put them out, 1 year before the current year is 2019. Your current, your previous, 2019. So you can use %eval or %sysevalf. %eval gives you the same result. I'll rerun this again. Same result. Uh-oh. You got to take off the F. All right, so we're good. Let's move to the next section and move on to call SYMPUTX. Remember, underscore null underscore means I want to use the data set, but I don't want to create a SAS data set because my purpose is to create some macro variables. Now, if you remove underscore null underscore, it will make work.data1 and work.data2 unnecessary. So we just don't want to create a data set. These are data set variables. YC, the year of today is the 4-digit year. I get 2020 for it today. And YP equals YC minus 1, I end up with 2019. Then I'm assigning 2020 to a macro variable called year and 2019 to a macro variable called year previous. Notice that on the left side, I'm hard coding the name to be exactly what I want. On the right side, I have the value variables where I may or may not know what they are. So remember what I said earlier, both arguments, and they don't have to be the same, assigned the same way, but they both could be specified as static in quotes. They could be the value of a variable or the value of an expression. In this case, this one's hard-coded, and this is the value of a variable for these two respectively. Then I'll do a put. I should end up with the same result, 2020 and 2019. The difference is, here I use sysfunc in %eval. Earlier, I just hard-coded the values and put them out. You can hard-code them. I have sysfunc calculate for you. Or you can use call SYMPUTX to do this for you. You can just run it next time, and it will do it automatically for you. 2020, 2019. We looked at an example of creating a series of macro variables. Student 1, student 2, student 3. If I show you the SAS help.class from me, then go to that library and show you the table called class, you get an idea of what it's doing. We have 19 students in here, Alfred, all the way through Wayne. We have their gender, we have their age, height, and weight. Okay? Just wanted to show you what those look like. So I should get that many iterations of the data set. And each time this iterates, I'm assigning underscore n underscore with the spelled out student to make it student 1, student 2, student 3, and so on. And whatever the current value of name is, that's what will be assigned. And then I'm just putting out the first, the second, and the 19th, and how many I have. When I get to the last observation on the set statement, I should have explained this earlier. This end equal option allows me to define a variable, whatever I want to call it. I can call it last, I can call it X. So here's the deal with this variable I'm creating. And it's a temporary variable, which means it will not be right now. This variable, whatever I put, will be 0 until I get to the final record in class. Then it will become 1. So when I get to the final one, create an additional macro variable called count, so I'll know how many names I have. Once you run this, all right, so Alfred, Alice, and William, and I have 19 names altogether. If I do a percent put underscore user underscore, you can see, you'll be able to see those macro variables. See all the students, you see Alfred, Joyce, Ronald, they're all in the global symbol table. Remember, the global symbol table is around your entire session, so you can take advantage of it. I've shown you percent let, where you know what the values are. I've shown you call SYMPUTX, where you don't necessarily know what the values are that will be assigned to one or more macro variables. Proc SQL enter says, hold on, I can do the same thing. You can also create a macro variable dynamically during execution when it does some kind of calculation for you. We have a SAS help table called PRD cell. This is what it looks like. We have actual amount, predicted, country, region, division, product, quarter, year, and month. Just wanted to give you a view of what it looks like. I'm going to make year equals itself plus 25. And I'm going to run this to data set step to create PRD cell. We've got year equal, this year, year equals year plus 25. So this is a data set that was created. And I'm going to use SQL to create one macro variable from the table I just created. And I'm going to take the value of year and get the maximum value of year. What I showed you a moment ago. Whichever one has the maximum value. Looks like that's what. So it's going to get that maximum value, put it out as a 4-byte string into a macro variable called year max from the table I just created. I'm going to put it out in the log, and let's see what it is. 2019. So you can ask for a statistic and put it in the macro variable. I changed it to the min, who will give me the minimum value. Right? Looks like just two of those. You can create more than one macro variable with SQL. But one thing I need to point out, you have to put colon in front of the name after the phrase into. Put this value into colon, this macro variable. You have to precede it with a colon. Let's look at creating more than one. These two expressions, they're expressions because they're doing some kind of manipulation with functions, for example. If I had 100, that's a static value. I can put that in your max. I could put 1,000, literally 1000 into that without having the expression if I know exactly what it is. But if I don't know what it is, this comes in handy. I'm going to put the max year as a 4-byte string and the minimum year is a 4-byte string. I'm using the put function. If you haven't seen it before, the put function writes a numeric out as a string. The reason I'm making it a string is because macro variables store text. So I'm assigning it a text value. even though when it resolves, it will resolve as if it's numeric. Well, to like we call it numeric token, right? So I'm going to run this. Let me put it out here in red again. Probably notice I like to highlight things this way in the log. To run this. And there's 2019, 2018 from that table, the minimum and the maximum. So I've shown you how to use the SQL into to create one macro variable, as in the case of your max, or multiple macro variables, but you have to have like a value or an expression. So I could put a comma and put another value, for example, make it 100. And I can just put colon, comma, colon, just call it number. So if you know a static value, you're welcome to do that. And then I'll put ampersand number. We run this. Let's see now if we get to do something. I'll have a period instead of a comma. There you go. So a quick fix, get this going. This little typo. Here we go. Here's the 100. All right, so you probably notice that it had more spaces here, and that's because it's using some kind of default format for the number. And I could put it out. Maybe that's the 3-byte string, and have more control that way. That's why I used the put function earlier. You see the spacing? It makes a difference. All right. What if I want to create several, or actually create one macro variable, but take a list of distinct makes and put all of those values separated with a space into this one macro variable? So check it out. Select distinct, or the word unique, car make, into colon, car makes plural, separated with a blank. There's a space between these two keywords that you can use with SQL. From SAS help.cars, I'm going to put them out. See what we get here. Now that's the report, and here's the list. Here's a list of car makes. Now what if I don't want that report, but I just want that list? I can do no print. And let's see, I'll separate with an asterisk instead of a blank this time. So why would you want a list like this? It might be that I'm doing some data validation. Let's say that I create a macro program with a parameter, and you're supposed to type one of these values. What if you mistype Chevrolet or Buick? Well, I might validate it and then show you what the list looks like, what's valid, and put it out in red. Number of reasons you can generate a validation list. What if you know you have 38 records in that table, and you want a make for each? You want each make to be assigned to one of these respective macros. Notice the syntax. Select distinct, meaning unique, make out of SAS help cars. Let me show you SAS help cars again. It has several records. You see Acura, Audi, BMW. The last one is Volvo, Volkswagen, Volvo. And I want a distinct, because I don't want these repetitious values. I want a distinct of each. The distinct make into, starting at make 1, the dash means through, make 38. So you need a hyphen if you want to put your end value. Well, I'll get back to that momentarily. But you have to put a colon in front of each range of the beginning and ending of that range of macro variables after the word into. Distinct make into colon the first one dash colon the end one. So if I run this, I'll just see 2 of the makes, Acura and Volvo. Remember, I could have done the no print if I don't want to report. Let's say I don't know how many makes I have. So this is a nice feature. I can just put a dash. Select distinct make into colon make dash. It will count them for me. Remember what I said earlier, whenever you use proc SQL, you automatically get that macro variable called SQL logs. It will tell you how many records were generated from your last proc SQL. And I'm only showing you two of the makes. I could show them all what a macro do if I had a macro program, but this is outside of a macro program. All of these activities. So Volvo, Acro and Volvo, there are 38 of them. What if I want to see the 5th and the 10th? And I don't want to report it, so I'm going to type in no print this time. And just show you that this works. If you don't want to see a report, you're only interested in grading macro variables, go for it. Cadillac, GMC, there are 38 of them. To investigate your macro variable storage, underscore all underscore shows you everything. It will show you the automatic macro variables plus any that you created. So how can you tell them apart? The automatic ones are the ones that SAS created for you. The global ones are the ones that either you created or the interface you're using created, or probably both. So I'm looking at some that will automatically be created from Enterprise Guide, but these are the ones that I mostly created, which you see here in the students. You can be explicit and tell it which macro variables you want. Remember, you can do the assignment, have location equals this value. You can use automatic macro variables or user-defined macro variables. We talked about that. For macro programs, you begin with %macro, give it a name, and to conclude it, you do %min, the same name, or you can leave it off. So inside of this macro is what I'm highlighting. That's what it's comprised of. It could be proc steps, data steps, or macro statements like %let, %put. It could be a call to a macro. So you really haven't seen the full strength of the macro facility. There's some power behind it. You can have it. You can create macro programs that can do a lot of work on your behalf and just use it whatever you want. So from here to here, it's defining it, and this is how you execute it. A semicolon is not necessary. It would be as if you put 2 here in this case. And let's put the second one in red. So I'll run this macro. This will create it. And then this will call it. If this is all you do, you will not see a result. You have to call it. The current time, 5:43:40. And the current date. So that's all this macro did. It actually just used sysfunc to get the date for today and write that out in word date. That's what word date looks like. And then systime to put the time out and AM PM. And you see the AM PM. Greater, display them. Here's a macro program that has parameters. And these are positional parameters. This make is a positional, that cylinder is positional. When you create the macro program and use parameters, you don't put ampersands here. It's only where in the code where you want them used, like here and here. So I'm filtering with this where statement, where make equals the make I specify when I call it, like 4. And then in the title, I'll put the make and then the number of cylinders, like 8. All right, let's try it. If I flip these two around and put 8 and 4, I'm in trouble. I will be guaranteed errors, pretty much. Here we go. Ford, 8 cylinders. Keyword. I like keyword because I can set my default values. Right, here's one of those cars I wanted, like Mercedes, Porsche, Audi's good, BMW's good. That's my wish list. All right. So percent cars, I have a keyword parameter. I'm assigning make my default Audi. All right. So you got a reunion coming up. I'm going to set that one as my default. Cylinder equals 6. And then my proc print, I'll filter for the make of the car equals Audi. Cylinders equals that number of cylinders. And in the title, I'll emphasize what I selected. And here's the conclusion. It does nothing until I call it. Well, it will actually define this. There's an option that will tell you if it's executed or not. So I'm going to run options in compile note equals all just to show you in the log that it was executed without errors. That's what that option does for you. The default is no in compile note. And it's only for when you define it, not when you call it. So here, notice I'm calling cars with no values. I better put that back so you can see what the defaults are. If I don't put anything, it will use Audi and cylinders of 6. Because those are the defaults. Audi 6-cylinder. But I can override any value. And I don't have to put them all. I'll put cylinder 4 equal to 4. The make will still be by default Audi. Yeah, 4 cylinders. So you can have a macro program with positional parameters, keyword parameters. You can mix the parameters up, but the positional must come before the keyword. I really like the iterative capability in the macro facility because I oftentimes want to do things repetitively against groups of data or a series of files. I'm using SQL to generate a list of my car makes and put it into a macro variable called makes. And I'm separating them with a tilde from SAS help cars. And then I'm displaying them. I'm going to type car makes colon so you can see my makes. I'll write it out in red again. Here we go. And I'm going to do this. And here we go. Let's see. Here we go. And so remember I separated them with a tilde, car makes, and we have them all displayed. Here's the next one where I have an iterative do loop within my macro program. So that list that I just showed you, this is part of the mix. I'm going to grab each one of these at a time. BMW, Chevrolet, Chrysler, Mercury, Mercedes-Benz, Lincoln, Lexus, Rover. I want to grab one at a time, like start with Acura. And I'm going to filter for each one. Notice I'm using a % scan. As I said, I'm going to scan for Acura first. I'm going to do a proc print filtering for those, the cars that have that make. Then when I go to the second one, it will be Audi, and I go to the third one, BMW, then Buick. That's what I'm using this do loop for. I will automatically be a macro variable. I can call it whatever I want. Start at 1. So when I is 1, think about it. I'm going against SAS help cars where the scan of makes in that list I just showed you, amper I will resolve the 1. Remember I said this is automatically a macro variable using the tilde as the delimiter. So it will grab that first car, which is Acura. So where make equals Acura in double quotes because macro triggers resolve, macro references and functions resolve within double quotes, but not in single quotes. And then in double quotes, I'm putting the exact make that I'm filtering for. So I should get 38 proc prints. Audi, BMW, beautiful. Volvo. Now this is just a straightforward example, but folks, in here in the do loop, it could be that I use an IO function to point to some shared directory or path. I can have it search for a certain file type like Microsoft Access or Excel and do something with every single one of those files that I find. It might be to create a SAS data set from each. There's a lot of power here with these do loops, macro do loops. What I could do is make a list of all my makes and actually put each make in a different macro variable. I'm just putting out a few and telling you how many I have. And we're going to run this. I'll create make 1, make 2, make 3, make 4, all the way through 38 or however many I have. And then remember I said SQL obs, you get that automatically. It will tell you how many records were produced. So Acura Audi, I just showed you 2, but there's a total of 38. Now check out this alternative. And this all calls macro. Remember this one? I can change it to say %do I equals 1% to ampersand SQL ops. And I don't have to create a macro variable count. I can use this automatic one. And it works precisely the same way. Same result as you saw just a little while ago. Acura, Audi, BMW. The power of the macro facility extends beyond iterative processing. You can do conditional processing, which is very powerful. We have one parameter, is positional, and I'm checking the automobile type, the automobile make. If it's Chevrolet or Toyota, remember that when we looked at it on the slides, percent then do a proc freak for that make, tables, cylinders. It's going to do frequency on those with a title indicating the make. If it's not one of the 3 that I'm checking, the 2 that I'm checking for, then just print the automobiles from that particular make. So only if it's Chevrolet or Toyota will I get a proc free. For the other 36 makes, or whatever I shouldn't say 36 because I'm not doing it repetitively. For whichever one I specify, if it's not one of these, I'll get a proc print. So you can see down below, I'm going with Chevrolet first. And if that's my proc freak, frequency percent cumulative, make is Chevrolet. And for Toyota, I will also get a proc freak. It's Toyota. And what about Acura? I should get a proc print for Acura. This Acura. Very good. Very good. Now remember some of those options like imprint and mLogic. I could use those if I want to, so I can get a better assessment of what's going on. Now what if I mistype? What if I type something incorrectly? Well, I didn't account for that. If I run this, neither block of code will run. Well, it will attempt to do the proc print against SAS help cars, but the where will fail because there's a misspelling for the make. So it will at least attempt to do a proc print, right? But I mistyped it, so I get 0 observations. What if I wanted to see the code that was generated? Remember in print, I can do options. I type options in print. So at least I can take a look at the code that was generated from this. You see, make equal hour. Oh, I made a mistake. And print is very handy. mLogic is very handy as well. No, turn it back on. Okay. All right, let's move on down to the next part. Here's an alternative. I can do percent let make equals Chevrolet, and then percent if within a macro definition again. The make is Chevrolet or make is Toyota, percent then percent do the proc free, else do the proc free. Alternative. Well, an alternative, what we're saying here is an alternative to this. Right? So if it's Chevrolet or Toyota, do a proc break, just do percent else do proc print. So I could put that inside of the macro, and I could check with a percent let. But the emphasis here is that, check it out, this is not within a macro, but it will still work. That's the point. It will still work. So I said earlier, percent if, percent then need to be inside of the macro. That's not true. We changed that on us. You now have the ability, I forgot about it, you now have the ability to do this outside of a macro program. But be honest, I would probably still have it in the macro program because I may want to do things repetitively, something along those lines. But this is all you want to do, go for it. I've talked about mLogic and print. You can turn them off when you're done. This turns them on. I showed you mprint a moment ago. You can go to the log. mLogic shows you the beginning. mLogic also shows you the conclusion of your macro. It shows you the result of an if-then-else test. mLogic also tells you when it finished. Print shows you the code that was generated. And SymbolGen just shows you the resolution of your macro variables. So to be honest, I typically don't do all three, even though you can. Whatever works best for you. I normally do mLogic and print when I just want to see how the macro program is working. But if I'm having an issue with some macro variables, then I probably just turn on SymbolGen and possibly mLogic. That's how I debug. So you can see the beginning. You can see the assignment of the parameter. And if then condition is true, then you can see all of this proc free code. So that concludes this first lesson. Let's continue with the second part, and that's the not so straightforward basics. So here's a multiple choice question. Which selection is a valid reference to the macro variable name? Ampersand, name, and that dot. The dot disappears when it resolves. These are typical macro variable references. If you put the period at the end of each name, when the macro variable resolves to the assigned value, the period disappears. So why would you bother to use it? Well, you would need it if you have some text following the name of the macro variable that would compromise the name. For example, let's say that after city, you wanted the word sunshine, like Atlanta sunshine, Chicago sunshine. If you type the word sunshine after the Y in city without the dot, then the macro processor would interpret that macro variable name as city sunshine. It would not exist, and you would get a warning for that. So the period will be required in that instance. Here's some examples. Let's say we create these two macro variables, month and year. When two macro variables are adjacent, right next to one to each other, there's typically not a problem in resolution in terms of getting a warning. Percent put ampersand month, ampersand year. Well, ampersand month resolves to MAR, ampersand year resolves to 2020, not a problem. Let's go to the second percent put. Once again, ampersand month resolves to MAR, no issue. But ampersand year data, I want to put the word data at the year, and I get a warning because it doesn't look for year, it looks for year data as the name. And this is where the period becomes very handy. If you have text following the name of the macro variable that would compromise the name, then you need a dot. Now, if you have something like an asterisk where the dot is, that wouldn't be an issue because an asterisk can't be part of a name. So in this example, amper month is Mar, ampersand year in the period, all of that resolves to 2020, and the text data comes right after the 0. What if you need a dot between text? For example, let's say that I substitute the library as SAS help, and I want class after that. Well, the problem is ampersand live dot resolves to SAS help, and ampersand DSN becomes class. So if you're trying to print that data set, it looks as if it's in the work library, work.SAS help class. The appropriate way to deal with this is to put 2 dots. The first dot will be treated like a delimiter, and the second dot will remain there as text, and it works. How many times does SAS scan this reference? If you have multiple ampersands, pairs of 2 become 1, and there's a rescan process going on. While it's scanning, any macro variable references that are legitimate will resolve. Let's take a look. Well, the answer is 2. In this case, these 2 become 1, cities carried over, amper year, whatever value it is, resolved. Amper city and that value is a new reference. 2. Here's a perfect example. Let's say we have these 4 macro variables: year, var, city 2020, location 2020. Adjacent macro variables, amper city and amper year, you get an apparent symbolic reference not resolved because there is no macro variable called city. There's a city 20, but no city. That's why you received a warning. Let's try it again. I was trying to get year to resolve first, but it doesn't work this way. Let's go to the second one. 2 ampersands become 1. CITY is just plain text city. Amper year resolves to 2020, and we're left with ampersand, locate, ampersand, city, and 2020, and that's a legitimate macro variable reference. Amper city 2020 is Washington. Let's try it again. And here's the rule. Multiple ampersands force the macro processor to scan the macro variable reference more than once. 2 ampersands, as I was explaining on the previous slide, resolve to 1. And scanning continues looking for legitimate macro variable references and continuing to reduce any multiple ampersands like 2 to 1. Let's go for this example. This time we have 3 ampersands. The first 2 make a pair. They're reduced to 1. You keep going to the right. Ampersand var is location. It resolves to location. So far we have 1 ampersand for the 2. Ampersand var is location. So far we have amper location. Keep going to the right. Ampersand year becomes 2020. And the reference you're left with after the first scan is ampersand location 2020. And there is a legitimate macro variable reference with ampersand location 2020, which resolves to District of Columbia. Every pair of 2 become 1. The first 2 make a pair that reduces to 1. Amper var is legitimate, that's location. Amper year is 2020. And on the second scan, you resolve location 2020, the District of Columbia. There's another multiple choice. Which of the following are macro quoting functions that mask special characters of different meaning in text? What are the 2 macro quoting functions in the list of the choices? There are 2. Percent string and percent inr string. Those are the 2. If you can see the issue in your code, you can quote that text with one of these quoting functions. So here's a breakdown of what each can do. The percent string quoting function can mask or cover up the meaning of certain tokens, certain operators. It can mask and or not equal to and make those operators look like plain text. So for example, let's say you were doing a percent if ampersand a macro variable equal to, and you wanted to specify Nebraska or Oregon or Indiana. Well, if you don't use one of these quoting functions, OR would look like the OR operator, this one like the N operator, and not equal operator. You don't want them to behave that way in certain cases. So the percent string can make all of these different operators look like plain old text, letter A, B. They have no significance. This quoting function can also mask things like plus symbol, tilde, the semicolon, can make that look like plain text. It will remove the normal meaning. So don't be the end of a statement, but just be a piece of text, plain like a letter A. Percent NR string, no resolution string, does everything percent string does. But in addition to what percent string does, it also masks macro triggers like ampersands, percent symbols. Percent string cannot mask those, cannot change the meaning of those to look like text. But percent NR string, no resolution can. If you can see the issue, for example, if you see OR, you know you want it to treat like text, or you see an ampersand and you want those things to be treated like text, if you can see the issue, then use percent string or percent NR string. In this example, I want the macro variable step to be assigned a full data step. So I've used the percent string to quote or mask, cover up the meaning of the semicolon here and here. So what does that do? It treats the semicolons, these first two, like text, like you type the letter T or B, just plain old text. So they don't have their normal meaning. The last semicolon does. The last semicolon is the conclusion of the percent let, but the other two as if there's just plain text. Now, things that come in pairs, you have to take an extra step. For example, single quote, double quote, parentheses, things that come in pairs. You have to do an extra little work. Put a percent symbol in front of that token or that item. Things that come in pairs. Percent single quote. I'm trying to make this apostrophe, employees report. What about macro triggers? Percent string cannot help us with macro triggers. If percent string cannot quote or change the meaning of those to look like text or behave like text. But percent NR string can. It can mask the ampersand and it can mask the percent symbol. So in this case, percent let company equals, I'm trying to specify R and D, but I know that ampersand D would look like a macro variable reference and the macro processor will go look for it. So to prevent that, to make this ampersand behave like plain text, like you type a B or C or D, plain text, you use percent NR string for no resolution attempt. Percent NR string can quote or change the meaning of ampersands and percent symbols, percent string cannot. So if you can see the issue, semicolon, quotation mark, ampersand, percent symbol, you can use percent string or percent NR string, whichever is appropriate. But what if you can't see the value? What if you can't see the text? So for example, let's say that in a data step called SYMPUTX or SQL, we are assigning a value to the macro variable company. And we're not sure what the value is because we can't see it. What you would use instead of the two we saw previously would be SuperQ. Now the question here is which SuperQ has the correct syntax? It's the first one. You put the name in the macro variable, and when the value resolves, SuperQ will quote or change the meaning of any tokens that would cause you an issue, like an ampersand, like a percent symbol. It would mask what is resolved. We can't see it yet. It has to resolve. Percent SuperQ. In this macro check, I'm checking a company that we specify when we call the macro. And I'm trying to indicate Oregon Insurance. But there's a problem. If if I had ampersand company and it resolved to Oregon Insurance, that OR would be interpreted by the percent if as an OR operator. I don't want that. So I'm using percent super Q so that when this resolves, that OR would be treated like text. So why don't I use ampersand instead of super Q? Because when I'm looking at this, I cannot see what the value of company is. Now, when I call it, I know I'm typing this in, but the deal is this still resolves to whatever that value is. And when it resolves, it will cause an issue. It would be as if you're saying percent if ABC not equal to, or it's like you put the OR operator, insurance. All right, so since we're masking whatever this resolves to, if it's not equal to ABC, we put not a match. Here's the end because I have a do block. Percent else put match. Okay, so the answer for this one will be no match. You don't need to put a leading ampersand when you use SuperQ. It will know this is a macro variable. Let's try a different approach. Let's say I run the data step when I'm only interested in creating the company macro variable and assigning it the value of Smith and Jones. This is a call SYMPUT example where the name of the macro variable is in quotes and the value is in quotation marks too. Percent let new company, I'm making a new macro variable, equals the super Q, percent super Q of company. And then I do percent put, the new company is ampersand new company. Because of super Q, when this resolves and gets assigned here, that ampersand is treated like text instead of a macro trigger. So Smith and Jones will be assigned here as text, the entire thing. And when it resolves, no issue with trying to resolve Amper Jones. That ampersand is treated like text. The meaning of it is changed. It no longer means what it normally means because I quoted it or changed the meaning of it to look like text for super. There's another multiple choice. Which option enables the macro processor to recognize the in operator for checking things in a list? It is the M in operator, the macro in operator. You have to turn this option on if you want this to behave like a macro in operator, as opposed to the one that normally works with the where statement. It looks like this. When you define a macro program, whether you have parameters or not, you have to put a forward slash, put M in operator. That stands for macro in operator, such that on the percent if, ampersand, for example, type, checking the value of this macro variable to see if it's in this list. For this n to be treated like a macro in operator, you have to use this option. And what it will do is check to see if it's SUV, truck, wagon. If it's one of these, percent then, percent do whatever. No quotes needed, no commas needed, no parentheses. And here's the second one. If it's in sedan or sports, then do something else. Don't forget your percent symbol. Instead of the word in, you can use the pound sign if you like. The pound symbol would mean the same thing. The default delimiter is a space, but you can also define what the delimiter is. Here it is, macro in delimiter. You put in a quotation marks, and in this case, we're making it a comma. So now it reads and separates things with commas. All right, so what I'm going to do, I'm going to switch to my EG session again and just go through the examples that I showed you on the slide. I'm turning off any titles and footnotes that are still running that are global. All right, so here's the first example. Remember the one I did with month and year? And as I stated before, together next to each other, not an issue, they both will resolve. You get MAR 2020. Month is MAR, and for year becomes 2020, not an issue. This is an issue because I want the word data to come after 2020, but the way the macro processor will work, it will look for ampersand year data and not just ampersand year. So we will get a warning because there's no such macro variable called year data. Not resolved. And it writes it out as it is. It did not resolve. Month resolved, but not year data, because year data is wrong. The period is the delimiter, where we can use it to mark the end of a macro variable reference such that the name is not compromised with the word data. And this time, we get 2020 data because the period goes away when year resolves. That takes care of the issue. Here we go. The period gets removed when it resolves. So the point of these 2% puts, if you want a period, you have to put 2. The first one here goes away. For these two, the first one goes away, the second one stays as text. No period because you only had one. One period because you had 2. 2. One stays, the first one goes away. Let's look at substituting a library reference, which can cause an issue, and a data set name. With one dot, you are in trouble because amperlive resolves to SAS help and the period disappears. So after the P, you get amperDSN resolving the class, resulting in SAS help class. And it looks like one name. And it will assume it's in the work library, and you will get an error because there's no such data set. There's no SAS help class in the work library. You meant to put a period between SAS help and class. So to address this issue, you use 2 dots. The first dot gets resolved with the library. The second dot remains there as text. That's your answer. You need 2 dots in this situation. Bingo. And the law. Notes indicate SAS help.class. So if you have inherited programs with extra dots, or you have programs to protect yourself, that's what it means. First one goes away. Let's move on to multiple ampersands. The reason I would use multiple ampersands is if I want to try to build a reference from multiple macro variables perhaps, and I want to delay the attempt to resolve maybe one or more of those macro variables to get what I want. Let's look at this example. We have 4 macro variables. We got year, we got bar, city 2020, and location 2020. I want to use the value of a macro variable to help me come up with the name of another macro variable. If we put 2 macro variables adjacent to one another, really not an issue. Well, actually it is an issue. Let's look at this percent put. We do not have a macro variable called city. We have one called city 20, but not city. If I use this first one, I'm going to get a parent symbolic reference for city not resolved because I don't have a macro variable called city. Not resolved. Now, if I had 2020 after it, it would be a legitimate reference. So here's what happens. I use multiple ampersands. Let me explain what happened. There's a scan rule when you have multiple ampersands. From left to right, every pair of 2 gets reduced to 1. And while you're scanning, if there are any legitimate macro variable references, they get resolved. Then another scan is made to again reduce any multiple ampersands, pairs of 2 to 1. So let's think about this. These 2, I'm just going to type this in, become 1. After these 2 get reduced, we keep going to the right. City is just a piece of text. So that's carried along. Keep going to the right. Ampersand year is 2020, and it resolves. And so this is now a legitimate reference. Ampersand city 2020 is Washington. So if that's true, watch what happens. The first one, we got the warning. The second one, we get Washington because of the multiple ampersand here. We're using this to delay any attempt to resolve city until we get the full part of city to 2020. Let's look at the next one. This is how the next one works. The first two ampersands become one. Keep going to the right. Ampersand var. Remember, I made var equals location, right? So ampersand var resolves in location. And ampersand year is 2020. So from this reference, you get amper 2020, which resolves to District of Columbia. Let's watch. If this is true, I should get District of Columbia. Here we go, District of Columbia. We're using the value of other macro variables to help build a reference of yet another macro variable. Multiple ampersands. All right, so we'll move on to quoting functions. We talked about them on the slides, and now here are the programming examples. Percent string can mask semicolons. You can mask each one. You can also do it this way. You could have actually just used 1% string and mask the entire data stack. These two would be treated like text. This is the legitimate conclusion of that percent left. And so when we resolve ampersand step, it becomes data new semicolon x equals 1 semicolon, and the run statement following it will make it run. And we'll get one observation with one variable called x with a value of 1. Here it is. You got data new x equals 1 and a run statement. Working in one observation, one variable. So it worked because we masked the meaning of the semicolons with percent string. Percent string can mask semicolons, mnemonics like N and or, NE. Things that come in pairs, remember you have to put a percent symbol in front of it. So if I'm trying to make this possessive employees report, I'll put percent string in a percent symbol. So we get an apostrophe, employees report. Things that come in pairs, you have to do a little extra work and put a percent symbol in front of it when you're quoting a percent string. What about macro triggers? Remember I said that percent string cannot mask or cover up or change the meaning of macro triggers, but percent inr string can, for no resolution string. So I really want this to be R ampersand D. R and D. If I put R and D, ampersand D would be regarded as a macro reference, and it will go to the global symbol table. The macro processor will not find it in there, and you'll get a parent symbolic reference not resolved. So to address this issue, I use percent inr string around the ampersand. So it treats it like text. Then we get the D. This will resolve to the date we started that SAS session. I'm making company, remember, equal to the whole thing, the entire thing. R and D as of that date. So because of percent inr string, there is no attempt to resolve ampersand D. This is treated like text. So if you can see the problem, like I can see that this is a problem or this is a problem, you can use percent string or percent inr string, whichever is appropriate. Here I see that the semicolons will be a problem, so I use percent string to quote them. Take a look at this macro program. There's an issue with what this will resolve to. Look at what we call this positional parameter. This macro with this program with positional parameter. Amper company will resolve to OR insurance. And that's an issue because the percent if macro statement will behave like this. Percent if ABC not equal to or insurance, this would look like the OR operator. We don't want it to behave like the OR operator. We'd have some issues. I want OR to be treated like text, as if it was OR. So if I go ahead and run it, say, well, I'll take a guess and maybe it'll work, maybe it won't. Okay, well, it didn't. Okay, just referencing a character value found, ABC not equal to Amper company, it stopped. That's an issue. So to address this, I can use percent super Q. Remember we talked about that? Well, when you specify the name of the macro variable, you do not precede it with an ampersand. Super Q doesn't need that. If we rerun this, remember ABC not equal to this, put no match, else match. Just want to write it out. Let's run this with OR insurance, so we should get no match. Not a match. What if we do indeed put ABC? Match. If you want to mask macro triggers, let's say that I define a macro variable, we call SYMPUTX, or call SYMPUT, call it company, assign it Smith and Jones. So this is the hard-coded value, and this is the name, and this is the hard-coded value. All right? And let's see here. All right, so we do a percent let new company equals ampersand company. The problem is this will resolve to Smith and Jones, and ampersand Jones would look like a macro trigger. Macro processor goes to look for it. It's not there. You get a parent symbolic reference not resolved. And the place it goes to look is the global symbol table. So we'll run all of this, and I expect an error. New company Smith and Jones. Apparent symbolic reference Jones not resolved. So what we do is we change this to use super Q. Again, when you use super Q, you do not need to put an ampersand in front of the name of the macro variable. Okay, let me write this out in red again. You rerun this with super Q, superhero macro coding function. Company is Smith and Jones. No resolution attempt on this because this ampersand is treated like text thanks to super Q. So when should you use percent in our string and percent string versus super Q? If you cannot see the resolution of that macro variable, or you can't verify what it is, use super Q, because super Q will mask or change the meaning of whatever it resolves, that resolve value. Percent string and percent in our string is when you can see the value. You can see that it's a quote. You can see that it's NE or OR. You can see the issue. Let's move on to the in operator. Remember, we have to type on the macro definition, keyword or parameter or no parameters at all, / MN operator. That stands for macro in operator. It makes this in operator behave like a macro in operator as opposed to the one that regularly goes with if or where. If you don't use this option, it will treat this like text and not an operator. It would be as if you said %if whatever the type resolves to in, and that's just like typing the word car. So because we have this turned on, we're checking for values in this list. No parentheses are required. The space is the default delimiter. So if it's one of these, do a proc print filtering for that type. %if the type is sedan or sports, then do a proc freak on the make of the car for that type. So let's give it a shot. We're going to try, SUV. Here it is. Let me go ahead and throw a little title in here. So we can see exactly what type was selected. I'm adding this title to both the proc freak and the proc print. So we can see exactly what the value looks like. So let's try these three: SUV, truck, and wagon. Report for SUV, truck, and wagon. Let's try sedan and sports. It's a proc freak for the sedan. Here's the make, and also for sports. The next section is, let's see, what if I want to specify the delimiter? So if it's something other than a blank, in this case, a comma, just use M in delimiter. Okay. The macro in delimiter is a comma, and so it treats this as a separator instead of a space. Okay. All right. So that will conclude the second part of lesson 1. All right, we are ready to start lesson 2. Doing more with macro. 2.1, we will talk about SAS IO, or input-output functions. We will talk about dictionary tables, the DOSUBL function, however you want to pronounce it, and then macro termination and branching. So let's start with 2.1. Most of you, if not all of you, have done a proc contents. And when you look at the output from proc contents, there's some information, metadata information, that's more numeric versus character. For example, if you look at the value for observations, it's the number. If you look at the value for compressed, it's either a character yes or no. So some of the information's character-based, some of it's numeric. There's also information pertaining to like variable name, if it has a label. The reason I'm mentioning those is because there are functions that can be used in conjunction with %sysfunc, so they can be invoked to perform some action. So for example, there's an exist function that can verify the data set exists. There's an open function if you want to get certain information from a table, especially metadata information, you have to open up the data set first. And when you're finished, you should close it. There's attr C, attribute C, versus N, where you can get character-based information or numeric-based information after you have opened the data set, and using %sysfunc to activate that function against the open data set to get that relative information. There are also functions pertaining to the variable where you can get the label, the length, and the type. Here's an example of a macro program that references a data set, and we are illustrating the exist function. We have one positional parameter, and here's the test in the macro program, %if, %sysfunc, we are using sysfunc to invoke the exist function on the data set checking to see if it's equal to 1. If that exists function returns a value of 1, that means it was successful in verifying that the data set does exist. And if so, we will print the data set for the first 10 observations. Percent else, put a note to the log saying no, not a valid data set. In the second macro program, again with a data set parameter, I'm pointing out the use of the open function. Open, ATTRN, and close. You have to open up the data set before you can invoke the ATTRN, the attribute end function, or C. So we are using sysfunc to do an open. And what happens, there will be an identifier number associated with that open data set. And it will be assigned to whatever variable name we put here, like the data set ID, DSID. Next, I check the value of that macro variable we create with the open function on the table. If it's not equal to 0, %then, %do the following. So let's look down below. What happens when you open it, if it was successful, it will return a unique number, some integer value. If it wasn't able to open up the table, let's say it doesn't exist, it will return a 0. So we're saying if it doesn't equal to 0, not equal to 0, that means it was successful. Then I'm creating a macro variable called numobs. I'm invoking the %sysfunc, which will activate the attribute end function against that dataset ID. Remember, we assigned an ID number to it, and it will look at that ID number and know that is the dataset that it's referring to. And we will look for the NLOBS attribute, which is the number of observations. Secondly, we use the ATTRN function again to get a different attribute this time, the nvars attribute, which will tell us how many variables, the number of variables we have. And when we're finished, we can close the data set by closing the data set ID, that macro variable that we created, assigning it a specific integer value that's associated with that data set. Now we're setting it up almost like a % macro assignment. We're calling this RC, implying return code. We could call it X or Y, not a problem. Another function you may be interested in is the var type, to figure out what type of variable is in position 1, position 2, and so on. So in this third example, data 3, with one parameter, we invoke sysfunc again, checking to verify the data set does exist. If it does, %then, %do the following. We will assign it an ID with the open function, then determine the number of variables like we did before. But what's different this time is I want to count the number of character variables. So I make up a variable called char, char, make it equal to 0. The purpose is to count, use it to accumulate the number of character variables. I do a %do I equals 1, 2, amper numvar. You might recall that that will have the number of variables assigned to it, the number of variables in the table. And then we want to check each variable. So if I have 5 variables, this will be from 1% to 5. Remember the index variable I, and whatever you call it, will automatically be a macro variable. So let's iterate through part of this do loop. %if, %sysfunc, we are invoking the var type, which determines the variable type. Here's the data set ID that we define above, and ampersand I is currently 1. So we're checking out the variable type for the variable in the first position, from left to right. If it's equal to C, and by the way, quotes are not necessary, %then, %do, I have in %n, %let char equals the %eval of the current value amper char char plus 1. So we're adding 1 to it. We hit the %n, I becomes 2, still in range. Again, I'm using an example of 5. And we check to see if the variable in position number 2 is character. If it is, we accumulate again. If it's not, we do nothing other than hit the end and go back up. This particular end and go back up. All right, and when we're finished, good practice, close the dataset ID. We use %func, sysfunc to do that. We can also check external files. Instead of open, we use dopen and dclose. D stands for directory. We have a lot of capability here. We can open up a directory and search for files and manipulate them in a certain way. And especially if you have a series of files, you can do things repetitively. We explore that in the advanced macro course, but we will see some features here. Dopen will open up a dataset path, well, a directory path, and dclose will close the directory. Denum is a function that will tell us how many members we have in that directory. Dread returns the name of the directory member. So I can determine how many I have, how many different items in that directory, and read each one at a time. When I finish, I can close the directory. So in this particular macro program, I supplied a path. And then I use a file name statement. If you haven't seen it before, you can set up a file reference to that location, to that path. Next, %let the directory ID. Just like I open up a data set, I also have to open the directory. So whatever path you assign here will be substituted here. And notice I'm just using a name without an ampersand in front of it with this dopen. Next, the directory number, their num equals the %sysfunc. I'm invoking the denum function against that directory ID, and it will count the number of members and assign it to their num. Now I know how many I have. I could do a %do I equals 1, %2, however many I have, and I'm going to do a %include on the path I specify when I call the macro program. Use sysfunc to do a directory read on that directory ID for the first member of that directory. And I'm using source2 to show notes in the log. So basically, I'm doing a %include to reference. It's generally used to reference a SAS program, so it can be executed. And that's what we're doing in this case. And we're going through the directory one member at a time and executing it, assuming it is a SAS program. When we're done, %sysfunc, dclose, and that directory ID, we assign it to a variable just like we did with the open table. It could be a different name. And not only do we close the directory, but we clear the library reference. Well, not the library reference, the file reference to the path. And that concludes the macro program. The next section is on dictionary tables. And there are several available. The dictionary files track all kinds of information in your SAS session. For example, it tracks macro variables. It tracks the different libraries you have access to, the data sets in those libraries, every single column and every single data set. You can get all kinds of information from these dictionary files. Now, you can only access them with ProcSQL, but in the SAS help library, we have some views of some of these dictionary tables. They're very useful. Some folks are not aware, but in this course, we're making you aware of these. Two examples we will explore are dictionary tables and dictionary.columns. Tables contains information on known tables in every library that you have access to. Work, SAS help, SAS user. Dictionary.columns, when you use ProcSQL, can give you information on every column and every table. So you probably want to filter that down so that you don't get tons of information. We are using the ProcSQL describe statement to get a description of the table called dictionary.tables. Remember I said that the tables is one of those dictionary files that contains a lot of information. So in that dictionary.tables file, you can get what's called a live name, which has a library reference you set up, perhaps, or unless SAS set it up, the member name, okay, which is the name of a table, okay, and member type. So the member type could be, and I shouldn't have said the name of a table because you can have different kinds of files in a SAS library. Tables is one of those types, and catalog is another, right there. So as we give this a try, I want to filter down just for the SAS help.shoes table. I use procSQL no print because I don't want to create a report. I'm actually creating two macro variables, and I'm storing the number of observations and the number of variables respectively in the macro variables numObs and numVar with the into clause that we talked about previously. The information for these two columns are coming from dictionary.tables, where the live name is equal to, check out the %scan, we talked about that earlier. I'm %scanning the resolved dataset name SAS help.shoes for the first word using imperatives delimiter, so we end up getting SAS help. Secondly, the second word we filter from member name, and that's the second word, for example, shoes. We have an additional dictionary file called dictionary.columns. As I said, it has information on every column in every library in every data set in every library in your session. In this macro program called Freak, I have two parameters, one for the library, one for the variable. In my procSQL, I am concatenating with the delimiter dot the library name and the member name. For example, a library reference and a table name. Right? So I'm concatenating the values of those two columns and putting those into a macro variable called tables separated with a tilde. So I want perhaps a series of table names from dictionary.columns where the live name is equal to some library reference in uppercase and the name of the column is equal to whatever variable you specify. So the bottom line is this. My goal is to look in the library for every table, library name, that contains that variable. Perhaps I want to join those tables. An alternative to using these dictionary files are views of these files. In the SAS help library, there's a view called SAS help.vtable, which is a view of this file. And there's also SAS help.vcolumn, which is a view of the dictionary.columns. So you could use these if you like. Here's an example, and I'm using the data set as opposed to procSQL. So let's say you don't want to use procSQL, you use the data set. Remember we talked about data null, underscore null underscore, which is using the data set without creating a SAS data set. Here's a %let for an example, DSN equals SAS help.cars. In the data set, set SAS help.vcolumn, which is a view of dictionary.columns, n equals last, so I'll know when I get to the last record, where catx of the live name and the member name, such as the data set name, is equal to a specific, the data set that I specify up here. If the type is character, then count plus 1. This is a sum statement. I'm accumulating count for the character variables. Else, if the type is num, then numeric count plus 1. So I'm accumulating a character variable count, numeric variable count. If last, when I reach the last observation, do the following. I want to create two additional, well, actually I want to create two macro variables. One called ccount, which will have the count of the character variables, and then intCount, which will have the count of the numeric variables, so that I can put them in the title or use them elsewhere. And in 2.3, the DOSUBL function, I'd like to cover that. This function enables the immediate execution of SAS code that contains some text string in the as the parameter, as the argument. This function can only be used in the data set, and it needs to be invoked with percent. Well, it can be invoked with percent sysfunc. You don't have to invoke with sysfunc, but you could, and you can use it outside of the data set with this sysfunc feature. If the function returns a value of 0, the SAS code will be able to execute. If it's non-zero, the code will not be able to execute. This is an alternative to call execute if you used that in the past. So let's take a look. Again, I'm doing a data null because I'm using this function to help submit some code. I'm making a literal, which is essentially a proc contents, a complete proc contents set with a run state, all in quotation marks. And then I use the DOSUBL function against that variable that has that text, and I'm assigning it to a return code type variable, so I'll be able to identify if it's successful or not by checking that variable value or just checking the log. Next, text2 equals a proc print, data equals SAS help class for 10 observations. Here's a run statement. So that literal, which is a legitimate set, will be the value of text2, and again, DOSUBL will execute. In the next example, I literally put as the argument a text string, which is a proc step, looks like two proc steps, proc contents, and a proc print. So the point is, I don't necessarily have to assign these strings to other variables like text1 and text2. I can just use that as my argument. Not a problem. More on DOSUBL within a macro. So I'm writing a macro program with two parameters, the library and the data set start. Here's your data null. And I'm setting SAS help vtable, which is a view of dictionary.tables. I'm keeping the library and the member name, which is the table name, where the live name equals whatever I specify when I call the macro, such as SAS help. And by the way, notice I'm moving it to uppercase or percent uppercase, just in case you don't type it in caps, capital letters, which we didn't yet. And the mem name equals the percent uppercase of DSN start PR. So all the data sets that start with PR. You see the equal colon? Next, DOSUBL, proc contents against data equal, and I am specifying in this literal the concatenation of the library with a dot and the trim value of the name to construct this literal as the code to submit with DOSUBL. And then secondly, I'm doing a proc print equal, and again, I'm concatenating the value of the library with a dot with the trim version of the member or table name in this case. And concatenated with obs equals 10 in the run. So I have a legitimate proc print step. So we'll go against the SAS help library and look for the table that begins with PR. The data set, since we're reading from vtables, and we're checking for those that begin with PR, in the first iteration, the PRD cell 2 table will be processed by proc contents and proc print. In the second iteration, PRD cell 3, and then PRD cell, and then price data, proj, for DEF. They all begin with PR. Remember, I'm looking for those where it's equal to the start, that is that name start, like PR. You can process a series of tables that begin with, have the same prefix, so to speak. Again, using this within a macro. I have two macro programs this time. The first one I'm calling two procs, which has proc contents and proc print against the table name that I passed through this parameter. Right, so two procs will do proc contents, proc print. Then a macro called contents that reference a library, the data set start, which again, with tables that begin with a certain letters. Data null, I'm using the vtable, which is again a view of the dictionary.tables, I'm keeping just the library name and the member name, which the table name, where the live name equals whatever I specify when I call the macro, and move it to uppercase just in case I forget to type it that way. And the member name, which is the table name, equal to colon means it begins with % uppercase. I'm moving whatever I type to uppercase. Then the table will be the concatenation. I'm using cats with the live name dot the member name. Okay. Don't have to worry about the trailing blanks. So this function will take care of that. And then I use the assignment to invoke the DOSUBL to invoke that macro program. You see %2procs, and I'm concatenating that with the table name and a close parentheses. So I have a complete call to the macro program for every single data set in that library that begins with whatever text I specify. The last section, macro termination and branching. We will take a look at the return statement and the %goto statement. The %return will basically terminate the macro that's executed. The %goto will label a section we could go to and perform some task based on the value, perhaps. Here's an example of the return statement that will terminate macro execution. I have 3 parameters: a data set, a class, and a var. %if, and I use %sysfunc again to check for its existence. If it's equal to 0, which means it doesn't have a data set, we won't be able to set up a data set identifier with it. %put an error to the log, not a valid data set, and then return. It skips these statements and ends the macro program. So for a table like XYZ, we will get a note saying not a valid data set. Here it is. We can go to or branch to a certain section that we can control. Let's check this one out. %let position class equals the %sysfunc of the var number num function on the data set ID for that variable. Figure out what number it is, what position it's in. %if the position of that variable is equal to 0, that means it's not in the data set. Then %goto invalid. And if we jump to invalid, we're just writing out a note to the log stating variable is not valid. Next, position var. I'm using sysfunc, again, using var num, to look in this data set ID for the position of that variable. Maybe it's an analysis variable versus class. %if the position, the value of that macro variable is 0, that means it does not exist. Once again, then, %goto invalid. Where we write a note to the log, the variable is not valid. And lastly, %let var t for type, I'm implying. %sysfunc, I invoke the var type function on the data set ID for the variable position, right? That it wasn't invalid, so we're assuming it's valid position. And then %if that var type is C for character, then %do, %invalid branch, again, put a note log saying it's invalid. It's not valid. All right, %let data set ID, %sysfunc, close that data set ID, and then terminate the macro program. Return. And we'll see an example of this code momentarily. But before we do, here's a link to macro documentation. You can get online, and it's the 9.4 Macro Language Reference 5th edition. So you can save this as a favorite link. Other options, you get quick access to it. What I'm going to do now is move to the interactive session so we can try programs for the things we just looked at. And I'm going to start with, let's see, section 1 and lesson 2. I have a proc contents where I'm submitting this, and we have 5 variables. You have the variables at the bottom. You can see some are character, some are numeric. Now, I think many of you recall that you can do a var num and see the variables aligned from left to right. Well, in their order, you see name, and then the next variable. The first 2 are character, last 3 are numeric. So keep that in mind. First 2 are character, last 3 are numeric. All right, so I have data 1 macro program. The parameters data set, I %if, %sysfunc check to see if it exists. If it's 1, it exists. Then I'm going to do a proc print. Otherwise, write a note saying it does not exist. So I will use my favorite way of writing it out in red. So we will run this. And this data set does exist. Let's put a typo in class, run it again, and we should get a note in the log in red. Here we are. Not a valid data set. So that's working properly. That was an illustration of the exist function. Let's scroll down to the open function, attrn, to get attribute, numeric attribute information, and close function. So here's the parameter, %let DSID, I could have used a different name for the macro variable, %sysfunc, open that data set. Now we have an identifier, for an integer identifier for that table. If it's not equal to 0, then %do. So if it's able to identify, open up the table, it will have a value non-zero, and that means it was successful. I have %let numobs equals to %sysfunc, the attrn function, to go against that data set ID and look up the nlobs attribute. That's a numeric value that's returned in this sign here. And next we look up another integer value, which will be the number of variables. And I think you noticed that there were 5 a moment ago when we looked, and assign that to numVar. Then I close the data set. In my proc print, in my first title, I'm going to indicate the number of variables and the number of observations that have been assigned to these macro variables respectively, with sysfunc and the invoking these functions. So let's run this. Notice again, I'm verifying if we were able to open up the table. We will do all of this. If not, we will write a note to the log. So we will run this for the SAS help class table first. And that's successful. Look in the log, not a problem. And secondly, we purposely misspelled the name, mistyped the name. And we get a note in the log. In this section for the var type function that I showed you in the slides, let's take a look at that. Once again, I check for the existence of the table. If it exists, do the following. Assign a dataset ID to the open function on that dataset. And then I'll %let numVar. I'm using the iterative on that dataset ID, looking for the number of variables. Assign it the numVar. I want to count the number of character variables. So %let char equals 0. I could use X or Y. Check it out. %do I equals 1. %2 amper numVar. And you might recall there were 5 variables in the SAS help class table. Let's get back to this. So this should be 5, 1 to 5. Go inside the do block. %if this %sysfunc on the variable type to get the type of the variable based on that data ID. data set ID in position 1 initially. I is 1. Remember, that's automatically a macro variable. If it's equal to C, percent then, percent do, unit accumulation, percent let care equals the percent eval of its current value plus 1. So 0 plus 1 makes 1. Percent n closes that do block. This percent n, I will increase to 2, still in range because I know it's 5. Percent if the var type on that data set ID for the variable position 2 is equal to C, then we accumulate the value of care again by 1. If it's not, it doesn't do anything in that do block. It hits the end and it increments. And we will keep doing this until we exceed that number, which I know is 5. When that's finished, I close the data set and I print the data set. And I show in the first title the number of character variables. And I added, I'll just run it without this first. I added this line just to show only the character variables. So let me just run this entire macro definition in execution. So let's see, name, and the next column, those are character. The other 3 you can see are right aligned there in numeric. What does it say? You have 2 character variables. If you want to see those particular character variables on the var statement for proc print, which controls what you're printing, you can use underscore character underscore to see only the characters. You can also use underscore numeric underscore just to see the numerics. Good way to validate. The next feature we looked at is the dopen. Instead of the open for the data set, we're doing a dopen for a directory. So we can open up a directory and explore the members of that directory. So you will supply a path to run programs, and I'm associating a file reference, my directory, with the path. To open it up, I use %sysfunc dopen on that directory path. And again, don't put an ampersand here, put a dopen. Dir num, I'm using sysfunc to invoke the dnum on that directory ID. That will tell me how many members I have. Then in the do loop, I'm incrementally moving from one to the next. %do I equals 1, %to however members I have in that directory. And I'm doing a %include. Some of you may have used a %include, but basically you point to a SAS program. Source 2 will show you what the code looks like. So I'm using sysfunc to do a directory read on the directory ID for the first member because I is 1. And it will try to execute that file. Again, going with the idea as a SAS program. I hit the end, I change it to 2. Here comes the second pass. I will capture the second member and %include was submitted to be processed the next 2. And we will keep doing this until I reach to the end of, I reach the last member. Then I close the directory, I clear that file reference, and I am going with this program. Here's the path. It is different from yours. And if you take a look, here's the path I just referenced, SGF, and there's a folder in there called program. Here's programs. I have one called data step and one called proc step, these 2. Those are the only members of that path, and they're SAS programs. Right, so we'll see how it works. Right, so we define, this is old code. Let's see, we define, we run this on this path. Here's run programs. I have mlogic turned on, so that shows me the beginning of it. And you can see the path specified programs. I set up a file reference to it. And as you can see, we would reference the data steps.SAS program. So that's the first one it finds. And it also finds the proc step.SAS program. Here we go. And it will execute both. If you look at the plus symbols, that's percent include. So what I'm going to do is turn off imprint, and so you can see clearly more of the information relevant to the source 2 option. I'm also going to do no M logic, turn that off. So no imprint and no M logic, and I will rerun this and check the log. And I still have symbol gen turned on, but you can see now percent include as source 2 shows the code that was coming from those programs. There's a proc print, and looks like a proc contents, proc print, and proc read, and proc means in there. There's also a data set called new packs. It's creating a data set, and one called shoe subset. So all the code in those programs will be executed. So this will conclude lesson 2. Thank you so much for joining us today. You have my contact information. If you have any questions about what we covered today in this course, feel free to reach out to me. I teach the SAS macro course, level essentials 1. I also teach the advanced course. I teach most of the programming courses and SQL. So feel free to reach out to me. So we certainly, again, appreciate your time, and have a good day.